In today's lesson, we will still be factoring, but we will be factoring special cases. So you should remember the lesson where we multiplied special cases. So now we're going to have those exact same trinomials and binomials, but we're working backwards. And if you remember, when we were working with the special cases, what showed up all the time is perfect squares. So just a quick review, perfect squares, you should recognize most of these. 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, 10 squared, all the way up to 20 squared. So you should really have most of these memorized, or at least be able to recognize when you see a number, oh, yep, that's a perfect square. So get to know these numbers very well. Alright, so here's a quick review. Don't need to write this down. Let's just kind of go over when we multiplied special cases. So if you have a binomial squared, x plus 3 squared, it means x plus 3 times x plus 3. And you had a choice where you can FOIL to get your answer, or you can follow the pattern. Perfect square trinomial. Let's see, we know we have to square the first term, x squared. And we're going to have to square the second term, 9. But then to get this middle term, this is when you multiply x times 3, which is 3x, and double it. So plus 6x. And then same thing for the second one. Let's use the pattern. If we square this, we get x squared. And then multiply these together. Negative 7 times x is negative 7x, and now double it. So negative 14x. And then square your second term. So plus 49. And then the last one, so the binomials are almost the exact same. The only difference is one is addition and one is subtraction. And if you remember, if you FOIL this, 2x times 2x is 4x squared. And what happens when you do the outside and the inside terms, they cancel out, because you'd have negative 6x plus positive 6x. So they cancel out, and then you do 3 times negative 3 would be negative 9. So in today's lesson, we're just going backwards. We're going to start with perfect square trinomials, or this is called the difference of two squares, and we have to go backwards, figure out what binomials gives you that trinomial. Alright, so for the first set of examples, all of the trinomials I'm going to give you are going to be in this form, a squared plus 2ab plus b squared, which means our first and the last terms will be perfect squares. So let's do the first example. X squared plus 8x plus 16. So you should recognize, let's see, the first term and the last term are perfect squares. The middle term does not need to be a perfect square. Now the thing with special cases, you can factor this just like you factor any trinomial. What are factors of 16 that add up to 8? But if you recognize that this is a special case, you can go straight to know, let's see, that our answer will be a binomial squared. And to fill this binomial in, we want to think square roots. What is the square root of x squared? It is x. And what is the square root of 16? It is 4. And then double check that it actually is a perfect square trinomial. That middle term, this has to be true. When you multiply x times 4 and double it, do you get 8? And you do. So if all of those are true, perfect square, and then when you square root them and multiply them and double them, do you get the middle term? Then what you get to do is just plug in x and 4 into your parentheses. Alright, the next one, n squared plus 16n plus 64. When you're factoring these, let's see, you always want to look for to recognize if it's a special case. Are your first and last terms perfect squares? And they are. And then square root them. So you get n and you get 8. When you multiply these together and double it, do you get 16? 8 times n times 2 is 16. So because that's kind of like the test. You want to first test, is it a perfect square? And if it is, you can go straight to your answer. It's going to be a binomial squared, and then you can just input n and 8. N plus 8. Alright, so now 4x squared plus 36x plus 81. Let's do the test. Is this the perfect square trinomial? Well, are my first and my last terms perfect squares? They are. So if they are, take the square root of them. 2x and 9. So let's continue checking. When you multiply 2 times 9 and double it, do you get 36? 9 times 2 is 18. Double it, you get 36. So that's your check. Yep, we have a perfect square trinomial, which means our answer is a binomial squared. And all you have to do is input 2x and 9. Now the cool thing about these, if you don't recognize that it's a perfect square, you can still just factor it using guess and check, or you can factor it using the AC method. This is just kind of a lesson on showing that sometimes you don't have to go through the pain of guess and check or AC method. If it's a perfect square trinomial, you can get the answer much quicker. So real quick, these two examples I'm just going to tell you, they are perfect square trinomials. So we're not going to do the test. Let's see how fast we can factor it. C squared plus 10c plus 25. It's going to be a binomial squared. Square root c squared is c. Square root 25 is 5. Everything is positive plus. And if you 5 times c doubled is 10. Good. And then the next one, square root h. So we have h. Square root 36. So we have 6. And that's a binomial squared. Quick check. Multiply these together and double it. Hey, we get 12. Perfect. Alright, so the second set of examples is almost identical to the first, so we're going to go quickly on these and you're going to try a bunch of them on your own. But to talk about the first one, n squared minus 16n plus 64. These are perfect square trinomials just like the first set of examples. The only difference is that one subtraction sign. But if you check, that's a perfect square and that's a perfect square. The square root of them, n and 8. And then 8 times n, double it, is 16. But because you have the subtraction sign, all that means is in your answer, you still have n and you have 8, but you're going to have a minus, a subtraction sign instead of an addition sign. So now that you know the concept of perfect square trinomials and all we're doing is changing the sign, I'm going to give you 4 examples and I want you to see if you can get them on your own. Alright, so pause the video and write these down and see if you can get the answer on your own and then come back and check your answer. So you should have gotten 3g minus 2 squared, x minus 4 squared, 2x minus 9 squared, and 8x minus 9 squared. Alright, let's move on to the next example. Alright, so let's think. Difference of 2 squares. You have 2 perfect squares, and the difference of them means you have subtraction. So what 2 binomials, when we were doing special cases, when you multiplied them together, what has to be true for that middle term to cancel out? We don't have a middle term. Well, that meant that you had 2 binomials that were the exact same except one was addition and one was subtraction. And if we're dealing with like perfect squares, we've got numbers being multiplied by itself. So if we're going to go backwards, we're going to square root. The square root of x squared is x. So x is going to be the first term in both binomials. And the square root of 64 is 8. So we're going to have plus 8 and minus 8. Because if you FOIL this, outside and inside terms cancel and you're left with just x squared minus 64. So real quick, to recognize when you have this special case, you look for, you only have 2 terms, and you have subtraction, and both terms are perfect squares. So the square root of 25 is 5, the square root of 64 is 8, which means your answer will be the two set of binomials, and it'll be 5x plus 8 and 5x minus 8. Alright, so I'm going to give you 3 more questions, and I want you to try them on your own. So x squared minus 36, 4w squared minus 49, and 9v squared minus 4. So see if you can do these on your own. So hopefully you got x plus 6 times x minus 6, 2w plus 7 times 2w minus 7, and 3v plus 2 times 3v minus 2. Alright, last set of examples. These are special cases that we have a step that you must do at the beginning before you can factor. Greatest common factor. So if you look at this first example, 10x squared minus 40. It looks like it's the difference of two squares because you've got subtraction and it's only two terms. But the problem is neither 10 or 40 are perfect squares. But what you should notice is they have a greatest common factor, and that greatest common factor is 10. So so this is like the opposite of the distributive property. If I divide both by 10, I am left with x squared minus 4. And now, look at what's left over. What we have left over is now the difference of two squares that we need to factor. So we still have the 10 out in front, and the difference of two squares factors to two binomials, and it would be x plus 2 square root them times x minus 2. So, continuing the idea of a special case, but finding a greatest common factor before doing the special case. Alright, so in this example, 3x squared plus 48x plus 192, this looks like a pretty complicated question to have to factor using the guess and check or the AC method. But the first thing you always should check every time is there a common factor between all three terms? And in this case, there is. The common factor is 3. So what you can do now is divide all of these terms by 3. And then whatever you get is what you have left over inside parentheses. If you divide them all by 3, you're left with x squared plus 16x plus 64. Now we can factor what is left over inside the parentheses. Let's see, the first and the last term are perfect squares, and when you square root them, you get x and 8, and x times 8 doubled is 16. Hey, that's a perfect square trinomial. So this is equal to the greatest common factor, 3, and then it's going to be a binomial squared. If you square root x squared, you get x, and square root 64, you get 8. So after you take the 3 out, you get a perfect square trinomial that you can factor. Alright, here are the last 3 examples. I want you to pause the video, write them down, try it on your own, then come back and check your answers. For the first one, you should have gotten a common factor of 6r, and then factored the difference of two squares to r plus 5 times r minus 5. In the second example, you should have gotten a greatest common factor of 3, and then you once again have the difference of two squares that factors to 3 times m plus 2 times m minus 2. And then the very last one, greatest common factor of 2, which leaves you with the difference of two perfect squares, which factors to 2 times 2y plus 5 times 2y minus 5. So there is your full lesson on factoring special cases. A lot of times you can still use the guess and check method, but this allows you to recognize when you have a special case, and then what's the pattern, what does it mean. So, good luck with the lesson. You can now factor anything that I give you.